So in each of these two problems, I set a little bit of a trap, by which I mean there's going to be something about each of these two problems that we haven't yet had a chance to talk about. So far, we've seen how to solve a compound inequality and use an and or an or to glue two pieces together in the appropriate way. And so we have here two more problems, the first with an or, the second with an and, that will ask us to do the same things, but when we actually sort of diagram them out, we might see that they're a little bit different in flavor to the ones that we've already seen. So let's start with the one on the left. X minus 4 is less than negative 5, or x minus 4 is greater than positive 5. What did you do to start solving this compound linear inequality? Add 4 to both sides. So we're, again, the same algebra as we would always do to try and get the x by itself in each of these equations. Luckily for us, that's only a one-step process in this particular example. Negative 5 plus 4, negative 1, and then 5 plus 4, 9. So there's each of our two pieces. X is less than negative 1, and x is greater than 9. And when I say and there, what I really mean is not and, because we're going to have to glue those two pieces together in a moment. Once again, I'm going to call them the blue piece and the red piece. Starting with the blue piece, let's sketch that piece on the number line. You may get to a point where you don't have to use a number line for this purpose, but until you feel really confident in these skills, I'm going to recommend every time, sketch it out. Use a number line. Don't be afraid, because it really, to me, as a visually oriented learner myself, I find that really does help me to understand the concept. If x is less than negative 1, how am I going to sketch that on a number line? Starting from negative 1, what should I do? Open circle. And we know it's open because it's less than and not less than or equal to. So negative 1 is not itself included. And which direction from there should I shade? To the left, because we're looking for x's that are less than negative 1. Okay. And then the piece x is greater than 9, I'm going to call that the red piece. That argues that I should go to 9 on the number line. And start with what kind of circle there? An open circle, again, because greater than, not greater than or equal to means that 9 itself is not included, and shade to which direction? This time to the right. X is greater than 9. So there are my two individual pieces. So now the question is, how do I stick those two pieces together using or? What am I looking for? What needs to be true here in order to be a part of our final answer? Which set does x have to belong to, blue or red? Either, exactly. So combine the two sets. So if I try to combine these two sets, what I'll find is that all of the x's which are less than negative 1 will belong to the set because they belong to the blue piece, but also that all the x's which are greater than 9 are going to belong to my set because they belong to the red piece. So that's something that's new to this problem. It's unique. I had two pieces, I ORed them together, and I still had two pieces in my answer. So what makes that different is that now, when I move to interval notation, how many intervals do I have to express? I'm going to have two separate pieces. I've got two, what mathematicians would call disconnected components. I have two separate parts that my answer needs to include them both. So let's take them one at a time. Starting with the purple piece on the left. What would be interval notation for that piece? What's its leftmost endpoint? Infinity, but it's infinity on the left end of the number line. So I would call it negative infinity. And then, as Silim says, negative 1 on the right. So there's the left endpoint, there's the right endpoint for this interval. And then let's talk through the square brackets or round brackets on that. So negative infinity gets what kind of bracket? Always round for infinities because they're not numbers and therefore we can never include them. How about negative 1? Also a round bracket because it's not included. So remember, round brackets, open circles, and strict inequality signs always go together, just to highlight where those are on the screen here. Strict inequalities like less than open circles like the one we have here, and round brackets. Those are all translations of the same thing. So anytime you see one of them, chances are you also see the others in your answer. So there's the piece on the left. With all that in mind, what does the piece on the right look like in interval notation? 9 is the leftmost endpoint. Positive infinity is the rightmost endpoint. What kind of brackets? Round. In both cases. On the infinity, because it's never included, and on the 9, because also 9 is not included. Again, round bracket, because open circle, because strict inequality. Those things go together. But I still have these two separate pieces. So I need to do something to communicate that both of those pieces are a part of my final answer. I need to stick them together. Anyone know what symbol that we can translate that into? Yeah, we translate that into a symbol that looks like this. It's a capital U. And if you want to look all professional, include no additional serifs, no additional cursive-looking strokes on this. It's not really a letter U. It's really a symbol that stands for union, which is what a mathematician would say we're doing with these two sets. When we OR them together, we're taking the union. We're taking in our answer every element which belongs in one set or the other. And so that capital letter U, again with no additional decorations on it, that becomes the symbol with which we glue these two sets together. So anytime your answer has two separate, disconnected components to it, we're stuck with using this union symbol to express our final answer in interval notation. So in our second example of a compound inequality on this screen, we again have two linear inequalities and a conjunction. This time the conjunction is and instead of or. And the conjunction we don't have to worry about until after we've solved each individual piece. So let's solve each individual piece. If 2x minus 9 is less than 11, then what do we know about x? Yeah, adding 9 to both sides and then dividing by 2 shows us that for that inequality, x is less than 10. So I'm going to right away move down to our number line and sketch the piece x is less than 10 by moving up to 10 on the number line, drawing an open circle. Again, open circle because strictly less than, and then shading everything to the left. So there's my first piece in the solution. X is less than 10. How about the inequality on the right? Minus x plus 1 less than or equal to 14. Subtract 1 from both sides. I'll get minus x is less than or equal to 13. And then how do I get the minus off the x? Yeah. So it is. Thank you. Thanks for catching that. Yeah, so this is negative 14 in the original equation, so I made a copy error. So that becomes negative 15. And then divide by negative 1. And that's going to get the minus sign off the x. It's going to turn negative 15 into positive 15. And what else is it going to do? It's going to switch the sign, switch the sense of the inequality, because we divided by a negative number. We divided by negative 1. So we have to switch the sign. And so that piece translates into the inequality x is greater than or equal to positive 15. So I think that means that, well, I'm going to do my best here. I didn't leave myself much space on the number line, so I'll just put 15 here. And then I will take and I want a closed circle this time because it's greater than or equal to. And then I'm going to shade to the right. So there is my second inequality. Now what happens? What am I supposed to do according to the conjunction and? What sets do my answer numbers need to be a part of? The blue set or the red set? Say again? So our answers need to belong to the red set, for sure. But when we're ANDing two sets together, we not only need our answers to be a part of the red set, but those same numbers also must be part of the blue set. So when we combine these two sets together, what we're really doing is we're overlapping them. So we're looking for the overlap between my two sets. Because I want, when I AND things together, both conditions need to be satisfied. So my final answer to this problem is an answer to the question, where does the blue set overlap the red set? Well, where does the blue set overlap the red set? What numbers belong to both sets simultaneously? None. There are no numbers which belong both simultaneously to the blue set and the red set. There is no way for me to pick a number on this number line, and visually we can think about that as just sort of, drawing a vertical line on this number line. There's no place that I can pick a number on this number line such that it belongs to both the blue set and the red set. I can find numbers which belong to neither, the numbers between 10 and 15. I can find examples of numbers which belong to one of those two sets, but there's no number that belongs to both sets simultaneously. So how would we phrase our answer? What is the solution to this compound inequality? So you said 15, so you have something like 10 comma 15, square over here, round over here. Everyone agree with that? Preston, what's going on with that? If I wrote this as my answer, what would I be saying? Yeah, I'd be saying here that those x's which are between 10 and 15 are my solution. In other words, that those x's are the ones that belong to both the blue and the red set. In fact, the actual solution is something of the opposite of that. This want in my answer the numbers which belong to both sets. But as you're telling me, there are no numbers that belong to both sets. So the set of x's which belong both to the blue set where x is less than 10 and to the red set where x is greater than or equal to 15 consists of how many numbers? How many numbers are there that solve both the blue and the red inequality? Delaney's shaking her head. How many numbers? None. So there are no x's satisfy this compound inequality. And that's how we would write it as a sentence. But in the interval notation, which typifies the answers to these problems, we have a special symbol for that. Yeah. We use a circle with a slash through it as our answer, which is not really a zero. It's a special symbol dedicated for just such a purpose. When mathematicians read this symbol, they read it as empty set. It's a set that consists of no elements whatsoever. It's the same as writing at the end of a problem, no solution. So that's the way in which this second example breaks our patterns. We can find each of the two solutions of each particular inequality separately just fine. We can discover the blue set, we can discover the red set. But when we're asked to AND these two sets together, we discover that they have no overlap. There are no numbers that are in common to both of those two sets. And therefore, no x's satisfy this compound inequality, and in set notation we say the solution is an empty set.